Wow. This place got away from me. Give me a second. And we're back with a much cleaner look. I may have just moved the boxes behind the camera so you can't see them, but you know, we're not here to talk about my lack of cleanliness. We're here to talk about why this 3D printer isn't currently printing the things I want it to. So, a little bit ago, I came out to find that this thing had failed, and this print had failed here. So, we'll show you this. This is supposed to be a print for a functional prototype of something we're going to use on the Hyper 10 array here. And I came out here and I saw this stringy mess going on here. What you're actually seeing here isn't stringing. This is a classic case of under extrusion. In fact, this is severe under extrusion. So what is that? It's essentially when not enough plastic gets spit out of the hot end to stick to your stuff. That's why there's layers of this. It was thin enough that it kind of just sort of solidified in place because it didn't stay liquid long enough to hit the ground. But obviously this is not a usable print. Severe under extrusion like this is really only caused by one thing: a severe blockage in your material feed setup. So in our quest to show you everything that can go wrong 3D printing, apparently, we're going to talk about that today. Under extrusion and fixing clogs, and we'll use our CR-10 behind me as a little example. Under extrusion has a lot of causes. You could have your settings wrong, such that your printer thinks it's extruding more filament than it actually is, and so you don't get quite as much filament as you think you're going to get coming out. And that can cause things like pock marks on the outside of your model, or missing lines or sections, or weird shrinkage problems. But they typically don't result like this. This thing is severe. And if it's this severe, and notice if we get this in close, let me bring this up here close. I don't know if you can see this. Let's see if we can get it to focus on that. See, this is it's a good print until this layer, give or take, and then everything becomes super floppy and completely not fitting everything. Well, prints only really do that when they have a failure in the feed. That means they either you have some settings wrong, or there's a bad portion of material and it gets clogged up in the nozzle. So in this hot end nozzle area here, it gets clogged up and that's it. Or if something gets stuck in this tube. So this is a Bowden tube. In a Bowden style extruder, you have a kind of motor up here that forces material through the tube and then into the hot end. So this tube is normally sitting right up here. I disassembled it a little bit just so I could figure out what was going on. So sometimes the linings in this tube get torn up enough that they cause binding on the material, or what'll happen is the hot end will actually heat up the plastic inside this tube end, and it will essentially make a big slug here that you can't push through. And but essentially they all amount to, you're now no longer able to get filament from your rack and from your spool into your build area here. So how do you figure out what's the problem? Well, first thing you should do, I already did that and I kind of had to disassemble it to figure out what else was going wrong here. Turn off your machine, or turn off the print, stop the print, because there's no reason wasting even just this little bit of material. Stop the print and keep your hot end at your extrusion temperature. In this case, I use about 205 degrees Celsius out here. And disengage your drive and try and feed it in by hand. So what this really does is, it's probably not the problem, but it does eliminate a drive issue. If you're, for some reason, if your drive is running really slow, or another way trying to work and not working, This would eliminate that. So just disengage. On the CR-10, there's a little flap back here you use to disengage the drive wheels, and then just try and feed it by hand. Most likely this will not feed or give you very, very, very little plastic. In this case, I could press really, really hard and get a little bit of plastic out, but I couldn't get much out. So then you're going to want to disassemble your Bowden tube and inspect your hot end here, as well as the tube itself. At this point, you do want to remove your material from the printer. I'm a little lazy and I just leave it hot and pull the material out of the extruder up top. This can cause some problems and might have contributed to my error here, but I'm just too lazy to do it any other way, and this sort of service is not too hard to go do. So when you're looking at this, you're looking for a couple things. In this case, our issue was fairly obvious right from the start. But you want to look and inspect your tube. Maybe grab some old filament. This is basically purely why I keep some of this really old bad filament around, is for these sorts of inspections. So grab some filament and try and run it into the tube. So this one probably won't run very well because it's got a really weird tip on it, because I did the second thing on it with it. And if your filament runs by hand in it just fine, it's not your tube itself that's the problem. However, in my case, I ran it down. It would run all the way down to the end of the tube here and stop. So I don't know if you can see that. It's right here. Can they see that? Can you see that? No, probably not. But right here, there's a slug of plastic. So what happened with my specific printer is it looks like I had a little bit of heat come up the hot end into the Bowden tube and melt a slug of the material into the tube, and then it basically wasn't going to feed any more material no matter how hard the motor itself was pushing it. So that's what happened here. The other thing that could happen is you could have, let's not put that on my weight, you could have a clog in your extruder, and that's pretty easy to check. What you want to do is turn on your machine, put it at extrusion temperature, and then just hand feed some material in. That's what I did with this thing here, and that's why these ends are kind of messed up. If the hand feeds in and easily extrudes through, it's not a clog in your extruder. If it is, you pull it back. If it doesn't feed through nice and easily, then you have something in your extrusion hot end nozzle itself, and that will require disassembly, more cleaning. Replacing a Bowden tube in this case is actually pretty easy. You just find the new one, go ahead and reinstall your fitting here. This fitting doesn't have to be super tight. It's not really there to be some sort of strength member or anything. Like finger tight, or maybe just slightly tighter than wrench, slightly tighter than finger tight. Get like a small little wrench, will work just fine. In this case, it pretty much exists only to guide the tube into the hole. Then you're going to want to take a quick look at the end of your Bowden tube and pick what looks like the flattest end. The flattest end should go in your extruder side. So the way the inside of the extruder works is this goes down and sits on a shoulder, and then the hole in the middle of the tube is what feeds into the hot end and the nozzle and through the extruder. If you pick one that's maybe slightly angled, what you're going to get is something like this. So this is, if you see the end of this thing, you see all these black marks and stuff. That is extruded filament that got out from around the edges, like it melted into the hot end and some of it came back up and got around the edges of our Bowden tube here. and that allowed some deposits and probably contributed to our problem. So the better the seal you can make on that shoulder, the longer your Bowden tube will survive in service. Just as an FYI, this phenomenon here of some of the material of your filament coming back up and out makes these very hard to remove. So I actually had to disassemble this to pull the Bowden tube out. That's not necessarily required if the seal's been really good or if you pull it out on a semi-regular basis, but this one definitely needed it. And if you're dealing with a clog, you're almost certainly going to need to put a little force behind it. Some printers will come with a little lock, this little blue thing right here that you just put on the top here to make sure that this thing doesn't disengage accidentally. Kind of locks everything in place. And you're good to go. So hopefully we can just turn this thing on, put a little glue back down on here, and start our next print. So, as you can see, the clearing part didn't work very well. There must be a bunch of stuff still stuck in there, so we are using the cold pull method. Cold pull method, I didn't necessarily plan on doing it in this video, but since we're doing it, we might as well. The idea here is that you essentially create a little plug that goes all the way out to the end of the nozzle, and then using heating cycles to get a plug formed, and then pull it out, and hopefully that pulling action with the plug will clean out everything that's kind of junky inside the nozzle here. So what the process is you heat this thing up to printing temperature. I did it a little bit above printing temperature, which in this case is about 220 degrees C for the filament I'm using, which is PLA. And then you insert it until some of it starts coming out the end of the nozzle. And at that point, what you do then is turn your temperatures down and try and get it down to, I mean, pretty close to solid for your material, or below the glass transition temperature, which on PLA is about 70 degrees. What you're trying to do is make sure that the strand that you have installed, like this one here that I'm holding, is solidly making a form of the inside of your nozzle. And at that point, at about 60 degrees or so, somewhere below your glass transition temperature, ideally, you can let go of the pressure and let your hands rest. Especially if you're like me and you've been working out a bunch where you haven't been recently because you left your beach body at the beach, that rest is handy. Then all you do is go heat this thing back up again to your printing temperature, and pull up. You're going to want to be careful with this if you're using a brittle-ish material. Ideally you want a strong but slippery style material. Something like nylon, but I don't have any nylon out, and I'm not going to pop it out just to do this. So if you're using PLA, well, I wonder if we got it. Hard to tell. You want to be very careful about when you're pulling it up, and then you want to provide constant pressure, and eventually the plug should come up. This one did, and because I'm using the same color PLA as the material that's kind of stuck in there, or some of the last material that was stuck in there anyway, it's hard to tell if we got anything out of that, to be honest. So we're gonna clip this end here and do a manual insertion again and see how she feels. It's so interesting. So what was extruding relatively like we would expect earlier, now with a Bowden tube, doesn't extrude well at all. Well, as you might be able to tell by this mess I've created here, the pull method didn't work, and it looks like there was either a much larger blockage in the feed than I thought there was, or I screwed it up. And I might have screwed it up using this new filament, but my guess is there was a much larger blockage, that the cold pull method, or at least what I was trying to do, wasn't working on pulling out. And I can show you that we have a huge blockage now. I don't know if you can see the end of this. Can you? Let's see if we can get this to focus. See that? That little gray thing in the middle? That's all hardened plastic in the nozzle that was just stuck there in the nozzle. And it's actually also stuck here in the heating element hot end, stuck here, and it's, you know, this thing will go all the way through the hot end if it were clear. It only goes that far, so we've got, heck, a good quarter to half an inch of material just stuck in here. So that was obviously this thing got super gummed up somehow, some way. Maybe it's this material, although it printed fine on a couple other models, so I'm not entirely certain what's going on with this material. But maybe we just screwed it up or something. But in any case, we're gonna have to get this out. So how I'm gonna do that is quite simple, or at least that's the idea, is I'm gonna reinstall everything here except for the heat sock and the nozzle, which is just super gummed up and really not worth trying to pull out at this point. And then we're gonna heat this up with everything in place, and then just try and force the rest of this stuff through. I've got this piece here which will fit, but I also have from my Raise 3D maintenance stuff. Frickin' moth, why are you here? Go away. I have this metal rod which is sized to go through these style and these size of nozzles. So I'm hoping I can just force it out with this and clear it out, and then we can install a new nozzle. We'll just junk this one since it's really not worth me trying to fix it, and then see if that solves our problem. So you saw me trying to clean out this bore area a little bit. Make sure there's nothing in here that's stopping our Bowden tube from seating. So we're gonna go reassemble here real quick and see if we can't get this thing back up and running here today. Look at that. Just a bunch of gross stuff. And you see all this black? I don't know if you guys can see all that. Let's see if we can see some of those black spots in there. So those black spots are old material that's just like burned in. So it looks like we were getting some clogging and clogging up over time, and this is just the leftover black stuff that we were having. I guess that could also be black filament material, because we print a lot of, you know, black PLA on this machine, but I don't think that it would be embedded in the gray like this unless it was left over and kind of burning up in there. So that's what it looks like we had happen here. So what I'm going to do here is I'm not going to save this or try and save this. This is just too much material. This is just not savable for a nozzle. Luckily they give you at least one, maybe two extra nozzles, so we can get up and get running again. But I think at this point I'm looking seriously at an hot end upgrade for this thing, just to give us a little more reliability, because there is not a whole lot of notice and this thing just failed on us. So I'm not super excited about continuing that, especially since I use this machine a great deal on some very large prints too, so I don't want it to fail in the middle of those things like it did on the last one. So let's get this nozzle replaced. It's pretty easy. We're gonna switch this machine off and cool it down a little bit, actually. And while it's cooling down, we're gonna take this little wire brush and run it through the hot end. Now that it's clean, try and get all the remnants of the crap that's in there out. So there's that. And the replacement for a nozzle is pretty easy. So you do a lot of it cold and then you heat it up and do the final little bit. So you grab your spare parts. I've got a bunch of spare parts stuff. I'll put up the links in the description down below. I've been meaning to put them up on a Thingiverse site anyway, so I'll put a link for you guys in the description to my spare parts bins that I keep up over here for parts and tools and that sort of thing. Keep them handy and nice and next to the machine. But you go in here and you get some spare pieces here, as well as another Bowden tube piece fitting up here, and they ship you with one spare 0.4mm nozzle, which I think I would prefer on this machine for it to be a little bit larger, but 0.4 is fine, especially since I really don't like the material changes on this machine right now. So 0.4mm nozzle kind of limits you on the amount of material you can put out, which I don't mind at all, because the amount of material we can put out is relatively about 1 kilogram or 1 spool in any one particular print that I'm comfortable printing this. So 1 spool in 40, 50 hours, 60 hours, something like that is about as long as I ever want to run this printer at any one point in time. So we're going to replace this. It's real easy. When it cools down, thread it on in most of the way, and then heat it up to 270 degrees, I think it is, or a very high, heat it up to the upper temperature ranges of your extruder, and then go ahead and tighten it with your wrench. In my case, I actually pulled out a specific wrench. In case you're curious, it's a 6mm wrench is what these 0.4mm nozzles are. So tighten it up on your heater block here when it's hot, because that'll seat it properly for when it's hot, and then you can reinstall all your pieces again. Alright everybody, well, as you can see, I'm not going to touch it because it's still pretty warm, but the hot end here is back and disassembled. I spent the last 2-ish hours cleaning this thing, and it was just not cleaning up. There's a lot of residue and melted stuff in the nozzle end here. underneath where the actual nozzles would go, and that, in fact, I don't know if you'll be able to tell, but on this edge here, there's an actual lip of old melted plastic. So something's gone wrong with our hot end setup, such that we can't actually get plastic from here all the way through, even if we have a visual line of sight. We're having severe issues pushing material through. So what we're gonna do is we're gonna take this opportunity. So what we're gonna do with this thing is we're gonna take this opportunity with this failing hot end here to make a few upgrades to this this thing to make it print nicer and print better and get us better results, and hopefully get us a little bit more capability. So we got some parts coming in, and we'll make those upgrades next time we see this machine. In the meantime, I guess I am down one of my larger machines, which is a little sad, but we'll figure it out. Anyway, guys, thanks for watching. My name's Andrew. It's another Make and Break YouTube video. If you have had this problem where essentially what would happen is we cleaned everything, we had a pure good visual look all the way through the hot end, and then we tried to feed any filament through even without the Bowden tube, and the filament wouldn't feed through into the nozzle. So if you've had this problem and you have a solution for it that doesn't involve replacing and upgrading the hot end, definitely throw those in the comments section down below. If you have any questions about kind of the troubleshooting or stuff I did today, throw those down there too. And thanks for watching, guys. Yeah, my name's Andrew. Another Make and Break YouTube video, and we'll catch you later.